Hey everyone, Ms. Butler here. Have a video on indicators. There's not a whole lot of indicators on the AP exam, so I'm gonna hopefully keep this nice and short for you. Okay, so in chemistry, we're going to use indicators to mark the endpoint of a titration, and it marks the endpoint by changing color. So we have two choices. We can either use a pH probe and measure the pH during a titration, and then we know that when the pH spikes up, that the midpoint of that spike would be the pH at the end or at the equivalence point. Or we can use an indicator, and when it changes color, that's the endpoint. One thing I want to note, the end point of an indicator is not the same as the equivalence point of the titration. But what we can do is I can choose an indicator that has an end point that occurs at the pH, the same pH that the equivalent points happens, and then they would be the same. So the goal is to find an indicator where its endpoint, its color change, is the same pH as the equivalence point of the titration, versus maybe an indicator that changes color at a different pH range. Okay, so in themselves, indicators are weak acids. So I can write, here's my, I was gonna do HIN. Silly me, let's try that again. I did the IN minus. Try that one more time. So HIN is my indicator, and in the acidic form as HIN, it's going to be a certain color. It's a weak acid, so we know we're at this equilibrium. But as we break off some of the H plus and IN minus, we notice that the IN minus is a different color. So a weak acid is, or an indicator is a weak acid where the HIN form is one color and the IN minus form is a different color. So we can always write a Ka then. If I know the Ka of the indicator, or maybe I want to solve for the Ka of the indicator, I can do my products, H plus, IN minus, over the reactants, HIN, like any other weak acid. So when do you start to see a color change? Well, for the human eye, it takes about a 1:10 ratio of IN minus for the color change to occur. So really, I need to be able to see 1/10 of color 1. I need to start to see color 2 at a 1/10 ratio in order to see the color change. So here's where this kind of comes into play. If I know the Ka of an indicator, so let's say I'm given that number in the problem. So I know that number. I'm going to start to see IN minus at 1/10 the concentration of the HIN. And so what I can do is I can solve this because I'm given the Ka. I can solve for H plus, and when I have H plus, we can take the negative log to find pH. And what that will tell me is the pH that the color change will occur. What I just showed you is if we have an acid down here, so the predominant form is the acidic, HIN. That's where we're starting with the 10, and then I'm adding the base. So once I start to see the basic color change at 1/10, what I started with, we should be able to find the pH of that. The other option is, if I have the Ka of the indicator, I can solve for H plus, which will allow me to solve for pH. And we, as humans, are going to see that color change happen at a 1/10 ratio, but if I start with the base down low, then the IN minus is going to be the predominant form here, and so when I add the acid, that is the 1 in my 1/10, right? Because we're adding the acid to the base. So we still always do our products over our reactants. How do you decide if it's 1/10 or 10 over 1 to solve for H plus? Well, if I'm starting with the HIN or the acid in the flask, then the 10 goes on the bottom. If I'm starting with the base in the flask, then the 10 goes on the top. So here are a bunch of different indicators, and your book has different pictures like this, but the goal is that we're choosing an indicator where the color change happens at the equivalence point. So this is a strong acid, strong base titration here in red. You can see the big spike, and the pH at the equivalence point is 7. So I want to choose an indicator that changes color. If you look, the phenolphthalein is changing color from this clear, they don't show it as clear, like this yellow, here's my phenolphthalein, sorry, from this clear to the pink at around 7. Phenol red would be a good choice. It also goes from this yellow to the reddish pink color around a pH of 7. Methyl violet, probably not the best choice because the color changing is happening low at a lower pH of like between 0 and 2, right? So you want to choose an indicator where the color change is occurring. This thymolphthalein, not the best choice for a strong acid, strong base because the color change is happening at a pH about 10. Okay, and then you can see the weak acid titration curve. There's less of the spike, but we want to definitely pick something that's going to change color at the midpoint, right? So phenolphthalein would probably work, but maybe something like methyl red, not the best choice because it's going to be changing at a pH down here on the graph. Okay, here's a good practice problem. Indicator HIN is a weak acid with the pKa, so the negative log of, 10 to the negative pKa would give me the Ka. Beaker X has a pH of 3, and beaker Y has a pH of 7. If I put a drop of HIN in each beaker, okay, I want to know what the predominant forms of the indicator would be in each beaker. They give me some colors. HIN is yellow, and IN minus is clear. So let's take a look at this one. So the pKa is 5, which tells me that the pH of the color change is probably going to happen around 5 for this indicator. Okay, it might happen, what we'll find based off that formula I was putting with 1/10 is that it's probably actually going to change around somewhere between 4 and 6. So usually the pKa, if you subtract 1 or you add 1, that's the range of the indicator, okay? So I like to just put the middle of the range. Around the pH of 5, we are going to have a color change. Well, beaker X has a pH of 3, which is lower, right, than the pH that this indicator will change. It's more acidic, okay? And so that means the acidic one, right, is yellow, HIN. So I have a bigger concentration of HIN and a smaller concentration of the IN minus. So what are the predominant forms? We are going to have predominantly HIN in this beaker. It will be yellow because we have a lower pH than 5. In beaker Y, I have a higher pH than 5, so that means we have the predominant IN minus. It'll be bigger, and then we'll have less of the HIN in this form. So it'll probably be clear, and this one will probably be yellow. All right, we have bromocresol, green. It gives us the Ka value of the indicator. It's yellow in its HIN form and blue in the IN minus form. If we put a few drops in a strongly acidic solution, so I'm starting down here in an acid, and I'm titrating with the base, what pH will the indicator first change color? So in this problem, we are going from yellow to a lightish green to a blue, so we're going to try to get this green color because if the blue's showing up, that's going to turn the yellow green. So think of it this way. If I have my ice table, I'm essentially going to see this. The human eye is going to see this when we have a 10-to-1 ratio. When the IN minus starts to appear 1/10 what we started with, or what we have of the HIN, the yellow color, then the human eye will pick it up. So I'm going to take my Ka expression. I have my Ka value provided. I know that I'm going to start to see it when the base color, the blue, is 1/10 what it was when it was yellow. And so I can solve for H+. So I get 2.0 times 10 to the negative 4th. Let me put a unit so I'm not a bad teacher. We know that if we take the negative log of H+, that will give me the pH. So we will first start to see this greenish color occurring at a pH of 3.7. There's what you pretty much need to know on indicators to be successful on those couple of indicator questions on your problem set. Have a great break.